guys, welcome to today's tutorial. We are continuing with tutorial sheet 8. So we'll be doing question 8, 9 and 10. Okay, so have question 8. I'm sorry, I still did not manage to have a printout of the tutorial sheet, so I'm just going to be reading it out from the one that I wrote. So three children are trying to balance on a seesaw, which includes a fulcrum rock acting as a pivot. Okay, so we have this is what we have. They're trying to balance on a seesaw, so it's a seesaw, and we have a rock, okay, which is acting as the fulcrum or the pivot. Okay, so that's what we have. Now, right, I'll start afresh. Three children are trying to balance on a seesaw, which includes a fulcrum rock acting as a pivot at the center and a very light board 3.2 meters long. So meaning that this board is 3.2 meters long. Okay, so we have 3.2, and if the pivot is acting at the center, meaning the distance from the center to the end is 1.6 meters, and to the other end is 1.6 meters. That's what we have. Okay, now two playmates are already on either end. Okay, two playmates are already on either end. Boy A has a mass of 45 kg, so we have boy A seated here. We have boy A, and then we have boy B seated on the other end. Boy B is what we have. So boy A is 45 kgs, whilst boy B is 35 kg. Now we've been told that there's a third girl who is supposed to sit on the seesaw as well, and she weighs 25 kg. She's weighing 25 kg, and then we've been told to find the distance where this girl is going to sit away from the fulcrum. Okay, we've already seen there's X marked on the diagram. This is X. So we are trying to find the distance or the perpendicular distance of this girl away from the pivot. Okay. Now, if you look at the masses that we have, we've got 45 kg acting here, 25 kg acting here, 35 kg here. So 45 kg is acting 1.6 meters away from the pivot, and then 35 kg is also acting 1.6 meters away from the pivot. So these two, if we assume they are rotating, you can imagine that there's a rotation. So if this was to rotate, this will be in a clockwise direction, the same with this one. But this other force will have an anti-clockwise effect. Okay, so to find out the distance where this girl can be placed, we simply have to calculate the net torque. Right, now we know, of course, that the net torque for systems in equilibrium is equal to 0, isn't it? It is 0. So we'll have to calculate this distance. We are going to use this condition of equilibrium. Okay, now when we know that torque is the perpendicular distance multiplied by the force, so meaning we are going to be dealing with the weights here. Okay, meaning we are going to multiply this by G, multiply this by G, multiply this by G, where G is the acceleration due to gravity. Okay, so we'll say where G is equal to 9.8 newtons per kg. That's what we have. So we're going to be using the weights instead of the masses, right? So now I'm going to have to use the equal signs here. I'm not going to use the positive and negative signs to talk about clockwise and anti-clockwise directions anymore. I'm just going to take those that are negative on the other side of an equal sign, so that I remain with those that are positive on the other side, so that we can only have positive values. Okay, so now the torque on this side will be the perpendicular distance multiplied by the weight, which is going to give us 1.6 meters times 45 kg multiplied by 9.8 newtons per kg, and that will be equal to, the weight of the girl is going to be x, the distance x multiplied by 25 kg, which is the weight of the girl, multiplied by 9.8 newtons per kg, plus, because of the fact that we're having two forces this side, so we'll add the torque here and the torque here. So we'll have the distance of this torque is going to be from the pivot to the end where the force is, where the boy is sitting. So we'll have 1.6. Okay, I'll write this, 1.6 meters multiplied by 35 kg multiplied by 9.8 newtons per kg. Okay, that's what we have. So if I simplify this, I'm going to end up with the left side giving me 705.6 Newton meters being equal to 245x plus 548.8 Newton meters. That's what I have. Okay, so if I take the 705.6 minus 548.8, this is going to give me 245x. Okay, so if we simplify this, we are going to have 156.8 Newton meters, okay, being equal to 245 Newton x. Okay, so we'll have 245 newtons, 245 newtons. So x will have a value of 0.64 meters. Okay, meaning that the girl will have to sit 0.64 meters away from the pivot for the system to be in equilibrium. Okay, that's all we needed to do for this question. Yes, there. So now we go to question 9. Question 9 reads, a 172 centimeter tall person lies on a light massless board which is supported by two scales, one at the top of the head and one beneath the bottom of her feet. The two scales read respectively 35.1 and 31.6 kg. What distance is the center of gravity of this person from the bottom of her feet? Okay, so we have a board here. Nothing has been talked about the length of the board, but because of the fact that a girl who is 172 centimeters is able to lie here, meaning that the board has 172 centimeters in length. Okay, now we're told that just here at the head we have a mass of 35.1 kg. Okay, the scale at the head is reading that. Then the scale at her feet is, underneath her feet, is reading 36.1 kg. So that's what we have there. Okay, now we've been asked to find the center of mass of this person. Okay, this person is 1.72 meters long. Okay, we have to find that distance. Now, for us to find that distance, in short, we are supposed to just find the center of mass. Now, to find the center of mass, the formula that we use for calculating the center of mass of an object is x, where x is the center of mass. So, right, center of mass is equal to, mind you, an object is made up of a lot of particles, okay? A lot of particles. Now, to find out the center of mass, if we have a lot of particles, we usually take each particle and the distance it is from the reference point, okay? If we take by the reference point, I mean we can start from the feet, we can start from the head, we can start from the center, we can start from anywhere, okay? Since the question has asked us to find the pivot from the bottom of the feet, meaning our reference point will be just at the bottom of the feet there. So we are going to take, initially we are supposed to take each particle, all right, and then the distance that each particle is from the pivot, okay, or from the point of reference. But we cannot manage to do that because we are just only concerned with the two parts where we know the masses of each part. Initially, if we had to know the masses of each point of the body, we would have to use them all, but we do not know. We've only been given the masses of 2 points of this person's body, the head and the feet. That's where we have the scale at the head gave us 35.1, the scale at the feet gave us 36.1 kg. Okay, so we want to find that center of mass of this person. We'll use the separation distance between the particles or the points that we've been given from the reference point. So our reference point will be the feet. Okay. Now the formula we use initially is x1 m1 plus x2 m2 plus x3 m3 plus, that goes on, and depending on the number of particles we've used, and then we'll divide that by m1 plus m2 plus m3 plus, and so on and so forth. So if we had more, we would use them all. But in this question, we've only been given two masses: the masses at the feet and the mass at the just at the head here. Okay, so meaning we are going to use this as our reference points, which is the feet. Now, if we look at that, substituting into the formula, we're going to look at x1. What is x1? x1 is the distance that the mass 1 is from the reference point. So our reference point is just at the feet. Now the feet, which is our reference point, is also where the scale is placed. So that will be 36.1 kg. Now, the distance, of course, will be 0 because this is the same position where we are starting from, meaning we've not moved any distance. So our distance will be 0, which will be x, multiplied by the mass, which will be 36.1 kg, plus the second distance that we have is 1.72 meters, which is 1.72 meters, okay, multiplied by the mass, which is 1.72 meters away from the reference point, is 35.1. So have 35.1 kgs. Okay, everything divided by the masses that we have. So we've got mass 1, which is 36.1, plus mass 2, which is 35.1. Okay, so that will give us this. If we simplify, will be 0. So we'll have 1.72 meters times 35.1, giving us 60.2. That is meter kgs. Yes, meters kg. Divided by, we've got the masses now. If we add the masses, we are going to end up with 66.7 kgs. Okay, so now if we simplify this, if we divide, we're going to get the kgs will divide. That will give us 0.902 meters. Okay, meaning that the center of mass x, center of mass, is going to be equal to, we can just take this to centimeters just so that we can have a value that is that's looking a bit bigger. But of course this is correct, but I'm going to just convert it to centimeters, and I'm going to have 90.2 centimeters. Okay, so meaning that the center of mass of this person is 90.2 centimeters away from the feet. Okay, it was from the feet. Mind you, if we were to find the center of mass from the head, the value will be different. Okay, because then we'll be measuring from the head to the center of mass. But since we've measured from the feet to the center of mass, we have 90.2 centimeters as our center of mass. Okay, so I will make sure that I do question number 10 before the day ends. I'm still a bit held up with the examinations that are happening. So what we'll do is, I wanted to actually inform you that we will have a Zoom meeting. I want to schedule a Zoom meeting with you guys. We've done 2 topics already where we've just been using YouTube. So I wanted us to have a meeting, a Zoom meeting where we can interact, discuss some of the challenges that you've had with the tutorial sheet 7 and tutorial sheet 8. If there are some questions that you've not understand on how I was solving them, you can prepare and then bring them on during the meeting so that we can talk about them, we can discuss as a group. Okay, so you can discuss amongst yourselves when it will be appropriate. Of course, then through the class rep, I'll be able to communicate whether that would be convenient. I don't know how it will be, but a Saturday can be all right, which is tomorrow. I'm not sure. You get back to me, tell me what you want, and we'll work on that.